In this problem, we're asked to find the volume flow rate past point 1, which is located right here in the diagram. To find this, we will need to use the ideas of continuity, which says that the volume flow rate at point 1 is the same as the volume flow rate at any other point and is equal to the cross-sectional area times the fluid speed, and we'll need to use Bernoulli's equation, which I've written here. We also know that the difference in height between the fluid here and the fluid here is 0.102 meters, and that the cross-sectional area A1 is equal to 1.73 times the cross-sectional area A2 and is equal to 2 meters squared. The first step is to use continuity to find an equation for the fluid speed at point 2. We do that by saying that the fluid volume flow rate at point 1 is equal to the volume flow rate at point 2, and they're both equal to the cross-sectional area times the fluid speed respectively. Substituting in the relationship between A1 and A2 and then canceling out, we see that the fluid at point 2 is going 1.73 times faster than the fluid at point 1. Now we can use Bernoulli's equation to find an expression for the fluid speed at point 1. We first see that because point 1 and point 2 are located along the same horizontal line, these two terms cancel because h1 is equal to h2. We can then rewrite the equation by moving p2 to the left-hand side and moving this expression to the right-hand side and simplifying. The difference between the pressure at point 1 and point 2 is equal to rho gh, which is the pressure due to this difference in height. We can then cancel out the density on either side of the equation and substitute in the expression we just derived for the velocity of the fluid at point 2. At this point, we now have a simple equation here, which we can solve for the fluid speed at point 1, and we see that is equal to the square root of g times h, where h is the difference between the fluid height here and here. Because we just calculated an expression for V1 and we were given the value of A1, it is now possible to calculate the volume flow rate at point 1. We substitute in the expression and then plug in the numbers that we now know to find that the volume flow rate at point 1 is equal to 2 meters cubed per second.